All right, last year I presented the first half of my research. Went out, took a bunch of water samples, and this is what I did after I left last year. So, as we saw last year, I was doing an assessment of biological and chemical contamination in southern West Virginia. That's a really long project name. If I would have known it was going to be that long, I would have shortened it before I had to write it 12 times. But contaminants, for the purpose of this project, were divided into two different groups, biological and chemical. Your biological contaminants are anything that is somewhat natural. The two most common were human waste and sediment from logging, mining, etc. Also had chemical contaminants, which acid mine drainage, household chemicals, all that good stuff. My project focused on the Upper Guyandotte watershed, which is the one up there on the top, Elkhorn Creek, which is the one down in the bottom corner, and then Camp Creek, which served as our control group. All of these watersheds have trout in them, whether they be brown trout or rainbow trout. Some have both. It's outside of the confirmed native brook trout range. Most of these streams, it's a very strange area. It's low in elevation. There shouldn't be trout there, but there's so much cold water influence from mine discharge and natural springs that trout do survive. We chose rainbow trout for this experiment because all three streams have rainbow trout. Back in October of 2021, I did a very comprehensive panel of water chemistry tests. 7 of them. Out of those, only 2 of them really influenced experimental outcomes. Conductivity, which is associated with metals and metalloids. That's a chemical contamination indicator. And E. coli coliform, which is, for lack of a better term, poop. The conductivity in these streams, they were variable. Camp Creek had the lowest conductivity, which you can speculate it has the lowest amount of metals or metalloids. Upper Guyandotte was in the middle there with 324. Elkhorn Creek was the highest. For reference, most of your brook trout streams in the Mon National Forest, you're looking 50 to 100 parts per million for conductivity. For the E. coli coliform, this is where things get really exciting. Camp Creek had 1,113. Upper Guyandotte was at 3,000. Elkhorn Creek was at 11,000. And the EPA says you shouldn't do any recreational activities if it's over 410. This is what inspired me to do this project because I was aware of the effluent going into the streams. This is where we left off last time. The subwatersheds of the Pocahontas coal fields, which are Elkhorn Creek and the Upper Guyandotte, they've got higher alkalinity, more basic pH due to limestone and calciferous deposits and coal seams. They buffer some of the acid mine drainage, but not all the way. Higher conductivity and lots of E. coli because they have very little public infrastructure. And the Camp Creek watershed, which is in a state park, is protected. It's about as intact as it gets for southern West Virginia. So, after I left, I started working on designing a study. It was a 2-part study. It was supposed to be a 1-part study, but we'll get around to that in a minute. I was looking at the effects of contaminants on brook trout or rainbow trout reproduction. We got some rainbow trout eggs, and then some stuff happened, and then we had to go get fingerling rainbow trout from the DNR. The experimental design was pretty interesting. I went back to the same places I took my water samples in October 2021. Got 5-gallon bucket, got a gallon of sediment from each of the 5 spots I hit, put it in there, went to the next watershed, did all that in one day, and I got to fish that day too, so that was fun. But I got all that, and I brought it back to Glenville. And this is how we raised the trout. Those are Coleman coolers. There's aquarium chillers under them, and big Rubbermaid tates that we put the sediment in, and then we put water over top of it, and we shook them up real good, let them sit and settle for a minute. In theory, any of the contaminants that were in the sediment would have leached out into the water, and it was designed to continuously cycle through the system. We had the water temperature remaining consistent between 50 and 60 degrees Fahrenheit, which is about optimal for trout. Those were the aquarium chillers, which those things are really expensive. I'm very glad I got that scholarship. Thanks, guys. I couldn't have afforded to do that by myself. The oxygen demands were met by 550 gallon per hour pumps, and it was designed for continuous flow to simulate the hydrology of a stream where you have small particles of sediment moving all the time. So, experimentation began on February 22nd with rainbow trout eggs that were donated by the USDA. I monitored them daily, and I started classifying them as failure to develop, which means they just kind of crapped out before they did anything. Partially developed, they had tails or eyes or something that identified them as fish at that point. And then survivorship, we had a few survive, not many. So, it had to be cut short. There was extremely high mortality in this experiment, which kind of upset me. But most of the mortality was associated with saprologenia, which is an aquatic fungus. I didn't know there were aquatic funguses. But to keep things consistent with wild-type reproduction, we didn't administer any antifungals, and extant research shows that survivorship is about 20% without any kind of antifungal treatment in a hatchery system. So, looking at that, whenever you stack everything the way that it should be in respect to E. coli, you're getting a 90% or 94% linear correlation. Then we ran a lot of statistics after that. There was a statistically significant association between the treatment groups and developmental failure, and 98.9% correlation between E. coli levels and how many of them did not develop. So, as I've said, strong correlation. What I hypothesize may have happened was there is a mutualism between the saprologenia fungus and E. coli bacteria, among other bacteria that exist in the water. And that's probably why we got such high mortality. Once you get a biofilm, you can't get rid of it. For experimental phase 2, we took the tanks apart, drained all the water out of them, scrubbed them real good, and put rainbow trout fingerlings, which were donated by the DNR. Originally, I was supposed to raise the eggs all the way through, but didn't have enough eggs to make it happen. Every 5 days, I went out and pulled the fish out, counted them, weighed them, measured them, put them back in. And I fed them 2.5 grams of food twice a day for a total of 5 grams. The specimen mass, it went the way that I figured it would. The specimens in the Pocahontas coal seam streams, which is Elkhorn Creek and the Upper Wyandotte, they followed more of a linear trajectory. But the ones in Camp Creek, which is your pristine system, they grew at an exponential rate. Ran an ANOVA on all that stuff, and there was pretty significant effect for treatment. And the correlation, we ran the correlation for every possible thing we tested for. And the strongest one that we could find was conductivity and trout mass. So the greater conductivity, the smaller the trout. Also looked at the length of the trout. This one surprised me. The specimens in the Wyandotte treatment grew to be the largest average length, and they all grew on a somewhat linear trajectory. I hypothesized that part of the reason why they grew the way they did and prioritized length over mass for the Wyandotte treatment is because length is better than having mass in a wild type system where there's a chance that a bird or something's going to grab them. And even at that, there was a weak positive correlation between conductivity levels and length. So through the experiment, it was determined that biological and chemical contaminants play an equal role in the impairment and growth and development of trout in the region's fisheries. Biological contaminants are worse for trout reproduction, whereas chemical impairments are worse for juvenile trout. And then I got back to making maps, which I didn't realize I enjoyed making maps so much, but after being in the environmental science lab for like 15 hours a day, I was ready to do that again. Last time I presented, I showed a map. And then I started digging, I started consulting a bunch of people that I know, and I developed a roughly 1,000 stream list that I plugged into GIS. This is the West Virginia DEP's trout data, which is probably the worst of the open source data sets I found. I think there's like 150, maybe 200 on this. And these streams here are pretty significant because whenever the DEP designates a stream a trout stream, they have to protect it as such. There are several other streams that you're about to see that do not show up on that. This is the DNR and Trout Unlimited's data set, which is the same data set that I showed last time. It was the most complete data set. That's what I did. I have every one of these streams classified by the species present if they're known. I've been updating it. I actually need to go in and do another set of updates because from the time I made this PowerPoint back in June, we found another 70 trout streams. And this is me and a couple of my buddies back home that fish all the time. So this is just a side project. This data set is being continually updated. Eventually, I will plug everything into ArcGIS online. I don't want to share it publicly, but I've already donated the data I have to Trout Unlimited's Mid-Atlantic Cold Water Habitat Program, which I'm now employed by. So thank you guys for the scholarship. Special thanks to the USDA, West Virginia Department of Natural Resources. Dr. Skylar Chapman was one of my advisors, and my other advisors here with me today, Dr. Nabil Nasiri. Y'all give him a round of applause. This man made sure I didn't die in college, helped me through a lot of stuff. So thank you guys. If you want to see the full 80-page report, if you need something to read to go to sleep at night, just let me know. I will email it to you. If you guys got any questions, just let me know. Any questions?